I found it. What's up, guys? I'm here to teach you about the states of matter. Hope you're all ready to learn.
What the hell? Who are you? How'd you get inside this school, bro?
Yeah, like get out.
Wait.
Hey, is that ice I hear in your water? This is a great opportunity to learn about the solid state of matter, specifically for water.
Why would I care about dumb ice and where did you come from?
Don't worry about all that. Let me just explain. The important thing to know about solids is that their molecules mostly don't move, except for very small vibrations. Solids are able to stick together with something called intermolecular forces, which pull all the molecules together and keep them mostly still, like your ice. Notice how the cubes are mostly stuck together in one piece?
Yeah, is that because the molecules in the ice don't have enough energy to break apart, keeping them together?
Yeah, that's right.
Wow, I love chemistry.
My job here is done. Now to educate another young kid.
Crazy weather we're having, right?
I know, right?
You know what I can't stand though? The socioeconomic. What?
A little splash of water was from something called a liquid.
Oh really? I hate you.
Oh, you want to learn more about liquids, you say?
No, I didn't say that.
Oh well, if you insist. Well, the first thing to know about liquids is that they move a lot more than molecules in solids. Their molecules fold over and move freely while still being connected by intermolecular forces. Except the intermolecular forces in liquid are weaker than those in solid. Notice how the water I threw on you spread out and got everywhere?
I noticed.
That's the weak intermolecular forces in action. If I had thrown a solid at you, you would have gotten smacked in the face. So you should really be thanking me right now.
Oh, thanks. Chemistry is really cool, but I still hate you.
I love ice water. Time to go on a walk now. Sure is hot outside.
It is. Where did your ice go?
I don't know, where did my ice go?
Guys, chill. Your ice is actually technically still in your water bottle.
Sir, last time I checked, I can see
Yeah, there's no ice in
there.
here.
Let me explain. This is actually a really great example of a phase change from a solid to a liquid. What just happened was your ice melting into liquid water, and this was an example of a phase change occurring. This occurs when heat energy was added to the solid, which in this case was the sun, and the heat in the atmosphere. When the heat was added, this caused the molecules to vibrate more, which weakened their attractive forces. So when they were tightly packed, which we saw when we looked at the molecular structure of ice, the molecules became more spread apart, which initiated the phase change. In this case, because the phase change went from solid to liquid, this is also very closely related to temperature change, as the increase of heat is the entire cause of the phase change.
Alright students, I need you to heat some water for this experiment.
Okay.
Thank you, Mr. Sato.
You do know where that water went, right?
Yeah, of course, it disintegrated.
Close. It actually turned into the air all around us. You see that steam? That's actually the water.
Really? No way. Prove it.
So basically, when there's an increased temperature change, heat energy is gained. The heat energy turns into kinetic energy, and then this energy, involved with the molecules, causes them to get excited, which means that the molecules move around faster and more away from each other. They become less tightly packed, and they lose their liquid state and become glasses. This is what you saw in the glass, as hot steam. If you put your hand above the hot plate, right when it finished heating up, you'd be able to feel the humidity, and when you pull your hand out, it would be pretty moist.
Whoa, it is wet. It's crazy how water can become so many different things.
Chemistry is so cool.
Well guys, I'm glad you all learned something today, and I hope that after all of this, you can go out and learn more about chemistry. Bye.